Calculus 2, Review 2, Part 3. Integral secant cube x dx. Integrate by parts. Integral u dv equals uv minus integral v du. So integral secant x, secant square x dx. U equals secant x and dv equals secant squared x. Secant x tan x minus integral tan x secant x tan x dx. Secant x tan x minus integral tan squared x secant x dx. Pythagorean identity. Tan square x is secant square x minus 1. Secant x tan x minus integral secant x times secant squared x minus 1 dx. So secant x tan x minus negative integral secant x dx plus integral secant cubed x dx. The integral of secant is ln natural log secant x plus tan x. That gives us 1/2 secant x tan x plus ln secant x plus tan x plus c. Integral 1 over x squared plus 8x plus 15 dx. Simplified is integral 1 over x plus 3 times x plus 5 dx. A over x plus 3 plus b over x plus 5. 1 equals ax plus 5a plus bx plus 3b. 0 equals a plus b. A equals negative b. And 1 equals negative 2b. Therefore, b equals negative 1/2 and a equals 1/2. 1 equals 5a plus 3b. Integral 1 over 2 times x plus 3 dx minus integral 1 over 2 times x plus 5 dx. Let u equal x plus 3 and du equals dx. u2 equals x plus 5, which gives us du2 equals dx. 1/2 integral 1 over u du minus 1/2 integral 1 over u2 du2, which gives us 1/2 ln u minus 1/2 ln u plus u2 plus c, which is 1/2 ln x plus 3 minus 1/2 ln x plus 5 plus c. Integral 3t over t squared minus 3t plus 2 dt. 3 integral t over t squared minus 3t plus 2 dt. So that would be 3, simplified, that would be 3 integral t over t minus 2 times t minus 1 dt. T equals at minus a plus bt minus 2b. 1 equals a plus b and 0 equals negative 1a minus 2b. A equals 1 minus b and 0 equals negative 1 times 1 minus b minus 2b. 0 equals negative 1 minus b and b equals negative 1. A equals 1 minus b. A equals 1 minus negative 1, which equals 2. So therefore a equals 2 and b equals negative 1. 3 integral 2 over 2 minus 2 t minus 2 dt plus integral negative 1 over t minus 1 dt. Let u equal t minus 2, which gives us du equals dt, and u2 equals t minus 1, which gives us du2 equals dt. So 3 times 2 integral 1 over u du minus integral 1 over u2 du2 is 3 times 2 ln t minus 2 minus ln t minus 1 plus c. Integral e to the 3x cosine x dx. Rearrange to give integral cosine x e to the 3x. Integrate by parts. Integral u dv equals uv minus integral v du. U equals cosine x and dv equals e to the 3x. So cosine x 1/3 e to the 3x minus integral 1/3 e to the 3x times negative sine x dx. 1/3 cosine x e to the 3x minus 1/3 times negative 1 integral e to the 3x sine x dx, which gives us 1/3 cosine x e to the 3x plus 1/9 sine x e to the 3x times 9/10 plus c. Dx over x ln x to the 5. U equal ln x, and which gives us du equals 1 over x dx. X e goes to infinity, u 1 goes to infinity, x equals e to the u. So integral 1 to infinity u to the negative 5 du gives us negative 1/4 u to the 4 1 to infinity. So negative 1/4, 0 minus 1 equals 1/4. Limit n to infinity, n to 1 over n plus 2. So e to 1 over n plus 2 ln n. L'Hospital's rule states that the limit of a quotient of functions is equal to the limit of the quotient of their derivatives. D over dn ln over d over dn n plus 2 gives us 1 over 9 over n. E limit n to infinity 1 over n. 1 over infinity goes to 0, and e to 0 equals 1. A of n equals negative 1 to n minus 1 times n divided by 4n squared plus 1. Limit n to infinity, negative 1 n minus 1 times 1 over n divided by 4 plus 1 over n squared. 1 over n goes to 0. 4 plus 1 over n squared goes to 0. So 4 plus 0 equals 4, and 0 over 4 equals 0. An equals arctan negative 5n. Limit negative 5n is negative infinity. So arctan negative infinity is negative pi over 2. Summation k equals 1 to infinity. 2k plus 1 to the negative 1 minus 2k plus 3 to the negative 1, which is 1 over 2k plus 1 minus 1 over 2k plus 3. Sn equals 1/3 minus 1 over 2n plus 3 equals 1/3 minus 0, which equals 1/3. P series. Summation k equals 1 to infinity. 100 over the square root of k. 100 over k to 1/2. P equals 1/2, which is less than 1. Series diverges by P series test. P series. Summation of k equals 1 to infinity, 1 over 2k square root k. So 1/2 summation, k equals 1 to infinity, 1 over k to the 1 times k to the 1/2. P equals 3 over 2, which is greater than 1. Integral 1 to infinity, dx over 2 plus x to the 3 over 2. U equals 2 plus x, which gives us du equals dx. So limit t to infinity, integral 3 to 2 plus t, 1 over u to the 3 over 2. Limit t to infinity, integral 3 to t plus 2, u to the negative 3 over 2. Limit t to infinity, negative 2u to the negative 1/2, which gives us limit t to infinity, negative 2 times t plus 2 to the negative 1/2 plus 2 times 3 to the negative 1/2, which gives us 2 over the square root of 3. Integral 2 to infinity dx over x ln x squared. U equals ln x and du equals 1 over x dx. Integral 1 over u squared goes to negative 1 over u, which is negative 1 over ln x. 1 over ln infinity plus 1 over ln 2 equals 1 over ln 2. Cauchy integral. 1 over ln 2 is convergent.